Hi class, in this lecture we are going to talk about animal virus replication. How do viruses multiply? This is the big thing. In animals, it is a little bit different. The only two differences in animals versus the bacteriophages are what happens once the virus gets inside. So you have the first two steps where you have absorption and penetration. The third thing is uncoating. What happens is that the whole capsid goes inside the cell from the DNA or RNA to get out. It has to uncoat and open up to release the DNA or RNA. That is the only additional step. Then the last thing is release. Release in many bacteriophages build up the number of viruses, and the whole cell blows up and release outside the virus at once. In animal viruses, they have the membrane or take that membrane with them. Many times it will happen as they lead by the process called budding. One at a time, it takes a piece of it with them. So it is like a slow death to the cell because you start to see these slow little blips coming off the cell, and it takes some with the viruses. Eventually, the virus will die because it has no membrane around it. Instead of just one big explosion releasing thousands of viruses. So the one difference is the uncoating, and the other one is with the release. Either open up by an explosion or slowly kills the cell by budding to death. So that is what I want you to remember here. Okay, you can see here again, you have the attachment where the spikes bind to the receptors of the host cell. Penetration lets the virus into the cell. Uncoating, the capsid opens up and releases either the DNA or RNA. The synthesis produces viral components, and assembly constructs new viral particles. Once the new viral particle is produced, it takes part of the membrane with it. We call this release or budding. We see this a lot with animal viruses. Again, we talk about the host range and where the viruses infect. Some viruses are particular for where they infect. Others are extensive and depending on the type of the spikes. The spikes are the keys, and the keys bind to the logs. It depends on what types of logs are in cells. If the key are particular, they will only bind to specific cells. For example, hepatitis B only infects liver cells. It does not infect anyone else because the only log that can bind with their keys is the liver cell. Poliovirus can infect intestinal and nerve cells, so that key has a more broad range. It can infect both intestinal cells and nerve cells. And then, rabies virus is even more of a master key because it can bind to many different cells of many animals. Alright, so again, this just shows you a little video how the animal virus comes in, and again, I'll show you this real quick, and then you can pay attention and get a review of what I just talked about.
There are two mechanisms by which enveloped viruses enter host cells. In one of the mechanisms, the virion attaches to host cell receptors by specific proteins on its surface called spikes. The envelope of the virus fuses with the plasma membrane of the host, and the nucleocapsid is released directly into the cytoplasm. The nucleic acid then separates from the protein coat. In the second mechanism, the enveloped virus adsorbs to the host cell by specific proteins on its surface, and the virion is taken in by endocytosis. In this process, the host cell plasma membrane surrounds the whole virion and forms a vesicle. The envelope of the virion then fuses with the plasma membrane of the vesicle, and the nucleocapsid is released into the host cytoplasm. The capsid protein is then removed, releasing the nucleic acid of the virus. A naked virion also enters by endocytosis. Since the virus has no envelope, it cannot fuse with the plasma membrane. After being engulfed, the viral nucleic acid is released from the endocytic vesicle. The nucleic acid then separates from the capsid.
So this video shows you the different ways and explanation an envelope versus a naked. I just want you to understand that the virus gets into the cell, finds the right lock, and enters the cell. Okay, so again, once it comes in, either you have endocytosis, where the entire virus is engulfed and enclosed to a vacuole or vesicle, or you have fusion where envelope merges directly with membrane, resulting in the nucleocapsid's entry into cytoplasm. Last video is a real nice job of showing you how that happens. Alright, this just shows you the penetration and uncoating. Uncoating is just the release of the capsid so that the DNA or RNA can come out. I'm not going to expect you to know all the different mechanisms, and all I want is that once the capsid gets into the cell, it releases the DNA or RNA, and then it does its either cooperates in the lysogenic state or makes new viruses in the lytic state. Alright, and then replication. DNA viruses or RNA virus replicates in different spots. DNA typically are replicated and assembled in the nucleus, and RNA virus generally are replicate and assemble in the cytoplasm. Because positive sense RNA viruses already have the RNA, they can go right to the ribosome and make new proteins using their RNA. However, the negative sense RNA must be converted into the positive sense. Just keep in mind that there are some differences between DNA viruses and RNA viruses infecting the cells. Alright, finally, release. I have already talked about budding so that you can see the picture. This virus is slowly bleeding the cell to death, and what happens is the virus particularly comes up and take a piece of the membrane with it. The other one is the lysis, like a big water balloon full of virus particles. Eventually, the cell cannot hold anymore, blows up, and release all the viruses particles out. Those are the two types. Again, budding is typical with the envelope, and the naked virus released by lysis. Okay, this will show you again the nice little video about the release of enveloped virus. So if you like videos, this is a good one to watch.
Enveloped viruses are usually released from the host cell by a budding mechanism. First, viral spike proteins are inserted into the host cell membrane. Next, the inside of the host cell membrane becomes coated with viral matrix protein. The viral capsid then becomes completely enclosed by the region of the cell membrane into which the spikes and matrix protein are embedded, and the virus is released by budding.
This one just again shows you how the virus take a piece of the membrane. Hopefully this helps a little bit. Okay, concept check. Which of the following is the step found in the animal virus multiplication but not bacteriophage replication? Is it absorption, penetration, uncoating, assembly, or release? Which is in the animal but not in the bacteria? If you said uncoating, you're right. Good job, you got it.